Hello, ladies and gentlemen, and welcome to another episode of Multiplication. This time we're going to focus on the distributive property. Some teachers like to refer to this as the decomposition strategy. I like to include that just so you see that word decompose in there because, as you may or may not know, decompose means to break down. So what we're going to be doing is breaking numbers down. That is, we're going to be breaking numbers apart by their place value. A little brief prior knowledge check on that. What I mean by decomposing a number is take the number 326, for example. Students were taught back in around third grade, maybe fourth grade, that to decompose number by place value, we're going to break that up by each of the place values. So since we have a 3 in the hundreds place, that would be 300. We have a 2 in the tens place, so that would be 20. We have a 6 in the ones place, and when we have 6 ones, we have just 6. So 326 would be the same as 300 plus 20 plus 6. One more example, just to make sure you've got it. 672 would be the same as, we'll use a different color this time. The 6 is in the hundreds place, so that'd be 600. We have a 7 in the tens place, 7 tens would be 70. And we have a 2 in the ones place, and we have 2 ones, that would be the same as 2. So we're going to use that knowledge of decomposition and apply it to a multiplication. And the way we're going to do this is using what's known as the distributive property, which that word distribute, I guess I should point that out too, distribute means to pass out. So we're breaking things down and we're going to pass them out. And I know many of you might be thinking right now, well, why don't we just do math the old-fashioned way where we have 326 times 16 and you just have to multiply the bottom number by all 3 of the top numbers, and then you take that second bottom number and you multiply it by all of the top numbers. Well, if that doesn't tell you anything right there, this strategy can be extremely frustrating and confusing for many students. There's a lot going on in a very small amount of space, and in addition to that, this distributive property is something that you've been doing the entire time. You are distributing this 6 to all of the numbers up top, and you are distributing this 1, which is actually a 10, and that's why you always put that 0 in that 10 spot, but you're distributing that 10 to all of the numbers above as well. What we're going to do is we're going to actually put this number horizontally, much like you would see in an algebra class, and that's why many of you are thinking, well, this whole distributive property, didn't I learn that in high school? You might have, but really we want to learn that as soon as possible because we found that students are able to think much more algebraically, or that is in a step-by-step or logical means in order to be better problem solvers rather than just be memorizers, which is what many of us were taught to do while we were in school, myself included. Anywho, let's get back to our problem here. We're doing 326 times 16. Again, I've just written this horizontally to make the decomposition seem a little less daunting, and I will do this for the students as well. And actually for this one, I'm only going to decompose one of the numbers. We could decompose both, and we will get to that in class when we discuss something called the area model, but we want to start very simply here. Again, this whole process and the idea behind introducing the distributive model so early is to help students to get away from the scariness of this standard algorithm. So I'm only going to decompose this 16. It's very simple. 16 broken down into the tens place and the ones place would be 10 plus 6. I think everyone would agree with that. 16 is the same as 10 plus 6. And again, I'm leaving that 326 alone. Well, the distributive property tells us when we have things in these grouping symbols and we're multiplying, all we really have to do is multiply one set of grouping symbols by the other, and we'll get our answer. You guys know that. You've done that forever, right? Well, the distributive property says when you decompose, that same rule applies as long as you are multiplying. The key thing here, this distributive property, is when we're multiplying. But instead of just moving that 326 to one number, again, I have to remember that the distributive property says I need to distribute to every number in the other set of grouping symbols, in this case parentheses. So I'm distributing that 326 to 10 and that 326 to 6. And by doing that, I've changed this big scary problem into two separate problems. I have 326 times 10, and this is why I taught in a previous zero the importance of the factor of 10 and being able to move that 10 to the right, because we can just bring it right down and we don't have to do anything with it. But remember, we had the 326 had to be distributed to both numbers, so we also have 326 times 6. So there we've gone, we've changed this big scary looking number where we had to remember 6 different steps into two very simple third grade level single digit multiplication problems. And if you look closely, there are still 6 steps. 1, 2, 3, 4, 5, 6. But the way that it looks, the way that it's represented to the students, is much less intimidating to have to remember all this information in one small area. So I'll go ahead and finish here. 1 times 6 is 6. And again, they love this when they can have tens. 1 times 2 is 2. And 1 times 3 is 3. Over here with our 6, 6 times 6 is 36. Remember, you should have learned last year, anytime you have a number that's brought up top because it's a double-digit number, you have to add that to the next column after you multiply. So we're going to do the 6 times 2 first, then add 3. 6 times 2 is 12. Plus the 3 would be 15. So the 5 goes here, the 1 goes up top, and again we're going to be adding that after the multiplication. 6 times 3 is 18, plus 1 is 19. Now the only step we have left here to do is the last step that you would have done if you were using this standard algorithm over here, and that is to add both of your partial products together. We got a product for multiplying 326 times 10. We got a partial product for multiplying 326 times 6. And now we're going to add those two partial products together to get our answer. I'm just going to bring this 1956 over here to add. 6 plus 0 is 6. 6 plus 5 is 11. 9 plus 2 is 11. Plus 1 is 12. 1 plus 3 plus 1 is 5. 1, 2, 3, comma. And we have 5,216. I'm going to do one more example to make sure you have enough to do that on your own. Before I work this out, please make sure that you pause the video, give yourself a chance to work it out on your own, and then go ahead and click play to reveal the steps and to make sure you've done it correctly. So the problem that many of you were used to seeing back when you were in 5th grade in a textbook, you might see something like 824 times 72. All right, and let's see. We're going to, again, rewrite that horizontally with our parentheses. We want to make sure we include these parentheses early on in 5th grade because now in the state of Texas we teach order of operations, something that many of you didn't learn until 7th, 8th, or even 9th grade, depending on which school you went to. But we will be teaching order of operations. That's GEM-DOS or PEM-DOS, many of you learned it. Please excuse my dear Aunt Sally. Yeah, we're learning that this year in 5th grade. So this is just a nice little sneak peek that will help students later on. All right, so again, I could break up both of these numbers. We'll do that later on, and I'll make additional videos when the time is more appropriate. but we're going to do 824 times 72 by breaking up the 72. And that 72 would be 70 because we have 7 in the tens place. 7 times 10 is 70. And 2 times 1, since the 2 is in the ones place, is 2. So 72 is the same as 70 plus 2. Okay? And our distributive property tells us that when we have multiplication and two sets of parentheses, that we just need to pass out this 824. Doesn't matter if you draw your arrows on the top or bottom. Eventually your students won't have to draw them at all. But we're going to do that 824 times 70. And then we're also going to do the 824 times 2. Now would be a good time to write those vertically again, more of what you're used to. 824 times 70. Again, we're moving that 0 off to the side like we've talked about before, so it can just be brought down and we don't have to mess with it. We're still multiplying here. And then we had 824 times 2. And there we are. We've taken this really ugly problem, and I'm actually going to solve it over here first so that you can see that I'm doing every step exactly the same with this model here. This is simply a much cleaner way and a much easier way for your students' brains to process at the 5th grade level. Because let's see how nasty this can get when we use old strategies. In the past, you were taught to do 2 times 4 first. Everything in the 2's or in the 1's place. 2 times 4 is 8. Then they taught you to do 2 times 2, that's 4. Then they taught you to go and do 2 times 8, that's 16. Then they said, all right, now you have to go and do the tens place. And they didn't tell you really that you were doing the tens place. They just said you have to multiply that 7 by everything up top, and don't forget to put a 0 right there. Never really explained to us, at least not me in my school, never explained why we were putting that 0 there. It was just a memorization thing. They said just put it there and then go ahead and continue your multiplication with the next number. Again, next number could mean this one, this one, this one, but we had to remember that this 7 was our next number. All right, 7 times 4 is 28, so the 8 comes down, the 2 comes up. 7 times 2 is 14, plus 2 is 16. And 7 times 8, oh, I forgot to do that 7 times 2. Then 7 times 8 is 56, plus 1 is 57. Then they said the very last step, once you've done doing all that, add those two things together. We're not going to tell you why, we're not going to tell you what they're called, we just want you to add them together because that's how you get your answer. That's what we were told way back in the day. 8 plus 4 is 12, 2 at the bottom, 1 on top. 6 plus 6 is 12, plus 1 is 13. 7 plus 1 plus 1 is 9, and we have 5. So, if I did this correctly, 824 times 72 is 59,328. Let's go look at our decomposition model and see if we get that same answer. 7 times 4, because again, we already brought down that 0. We know we're not doing anything with it. It is 28. 8 on the bottom, 2 up top. Don't forget, anything we bring up top, we're going to add, not multiply. We do the multiplication first, then we're going to add. Okay, now 7 times 2 would be 14, plus 2 would be 16. So I'm going to go ahead, see, 7 times 2, that was 14, plus 2 is 16. Say that again, yeah. All right, then we have 7 times 8 is 56, plus that 1. Don't forget, we add what's on top after we multiply. We don't multiply it. 7 times 8 is 56, plus 1 is 57. You might already be saying, hey, look, yeah, that was one of our partial products from before, 57,680. I just did the second step first, but I'm still getting the same exact partial products, which will result in the same exact answer. Now here we have 2 times 4 is 8, and 2 times 2 is 4, and 2 times 8 is 16. And just like before, see if I can get my arrow to go the whole way. Look at that. 1,648, 1,648. When I add those two numbers together, something tells me we're going to get the same answer. That's our last step. Again, we were adding these together because we broke them apart. We have to add them back together to get our final answer. 8 plus 0 is 8. 8 plus 4 is 12. 6 plus 6 is 12, plus 1 is 13. 1 plus 7 plus 1 is 9. And 5 plus nothing is 5. 1, 2, 3, comma. 59,328. No matter which way you break it up, no matter which way you slice it, as they say, we're still getting the same products. So are we teaching your students any new math? Absolutely not. What we're simply teaching is a more algebraic way of looking at the problems to get all of this to look just a little bit neater. All right, I hope you enjoyed, ladies and gentlemen. Don't forget to take a look at our videos website on the 5th grade website for Lansbury Elementary. There are plenty more videos from myself as well as Rob from Math Antics and Con from Khan Academy to help you with anything else. Thank you. Have a good day.